In this session, let us see how we can obtain a variable DC output voltage. So there are two methods of obtaining a variable DC output voltage. First one is the pulse width modulation control or the constant frequency operation, and the second one is the variable frequency control. So in the pulse width modulation control, you can observe here there are two waveforms. Okay, this is the first one and this is the second one. So for both the waveforms, you can observe that the total time period is fixed, that is the t is fixed. This is the time period t. So for both the waveforms, you can observe t is fixed. But here, if you observe, the on period is varied. Okay, the on period is varied. So here the on period is very less, whereas here the on period is somewhat more compared to the first one. So the same thing happens with T off. Obviously, when you are keeping time period T fixed, if you increase T on, then T off is going to be less. So we have obtained the expression for step down chopper. What is it? VDC is equal to V into T on by T. So in this, we can obtain a variable DC output by varying the on time of the thyristor. So for this second waveform also, the expression is same. Expression is not going to change, but what is going to vary? It is the on period, which is T on. Here it is very less, very small duration. Okay, here it is a large duration one. So we will obtain a variable DC output voltage by varying the on period. So pulse width modulation control, we vary the on and off period of the thyristor which is going to conduct, and we keep the total operating time, that is T, the total time period T, to be fixed. Then what about the second method, that is so this pulse width modulation is also called as constant frequency. Why it is called as constant frequency? Because our time period T is fixed, so obviously frequency, which is 1 by T, this is also fixed. So constant frequency operation. So next is the variable frequency. Variable frequency means obviously this T has to be varied, right? T has to be varied. So to vary T, you see here this is the first waveform and the second waveform. If you see, that is the output waveform. T is not fixed, T is changed. But what is kept same? T on is kept same. So T on is kept same. So T, you know, is nothing but T on plus T off. So how can you vary T? You can vary T by either varying T on or by varying T off. So in this particular waveform, for example, this T on is kept fixed and this T off is varied. Okay, or what you can do is you can keep T on varying, but T off has to be fixed. So what will happen? The total time period T varies. Your expression is then of VDC, which is equal to V into T on by T. So if this T is going to vary, obviously VDC will vary. So this is a second method in which you can obtain a variable output voltage, that is by using variable frequency control. But most of the times what we do is we go for a constant frequency operation, wherein the total period of the chopper is being fixed, and what is going to vary? We are going to vary the on period of the chopper. So these are the two methods in which we can obtain a variable DC output voltage. So in the next session, we will see how does a step down chopper behave in the case of inductive load and how are choppers classified.